Okay. So here we are writing the slope-intercept form of the equation of the line. And I'm given a table. And so we have been doing this the past couple of days. Remember, a table of values is just a series of points. And so I'm actually given 4 points. So if we can write the equation of a line given 2 points, we can definitely write the equation of the line given 4 points. So I'm going to follow the exact same steps that I just followed, which is find the slope, step 1, step 2, find the y-intercept, step 3, put it together, plug it into the equation. So to find the slope here, step 1, I'm going to also do change in y over change in x. So I can pick any 2 points that I want and find the difference in y and divide by the difference in x. So I'm going to use, I'll just use these 2 points right here. And so I'm going to do, I'll move this way. So 6 minus 9, those are my y values, and I've got to move the same direction. I've got 8 minus 6 on bottom. So 6 minus 9 is -3, and 8 minus 6 is 2. So that is my slope, -3/2. And next I want to find my y-intercept. It's worth taking a look to see if there's any place where x equals 0, but that point is not included on the table, so I do need to solve. So I'm going to use y equals mx plus b. And I can pick any point I want once again. So this time I'll go with this point right here as my x and my y, where this is x, this is y. So y is 12 equals, my slope I just solved for is -3/2. X is 4 plus b. And so to multiply this fraction here, I'm going to multiply 4 times -3 is -12, and then divide that by 2 is -6 equals 12, and then I'm going to add 6 to both sides, and I get, this should be 18 equals b. And so I think it's worth pointing out as well that you should notice a constant rate of change. If not, I made a mistake when I made this table, but we should see a constant rate of change so that it doesn't matter what 2 points you picked, you should have gotten -3/2 for your slope. So let's see, in my change in y, 15, how do I get from 15 to 12? It's -3. 12 minus 3 is 9. 9 minus 3 is 6. So there is a constant rate of change in the y's. And on the x's, we have 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. So that is correct. And one side is going up, the other side's going down. So that's why it's a negative slope. So now that I have my slope and my intercept, I can plug those in. Y equals -3/2 x plus 18. So there we go. We're going to do the same thing over here. Find slope first. Change in y over change in x. Pick any 2 points you want. I can't avoid negative numbers, so I'm just going to I'll pick this point right here for my 2 points. So change in y, I'm going to do 4 minus -1, and then -6 minus -8. So these change to pluses, and I get 4 plus 1 is 5. -6 plus 8 is actually 2. So I have a slope of 5/2. Once I have slope, I'm going to get my y-intercept by using y equals mx plus b. I want to pick a point for my x and my y. I'm going to go ahead and use this one here as x and y. I could use any point, but this is the one I'm going to use. So I'm going to do 9 equals m is 5/2, x is -4 plus b, and that's what I'm solving for. So with these fractions, I'm going to multiply 5 times -4, which is -20, divided by 2 is -10. So I get 9 equals -10 plus b. And so I'm going to add 10 to both sides, and I get 19 equals b. So I have my slope, I have my intercept, I can plug those in. Y equals 5/2 x plus 19. There we go. All right, we're getting down to our last few questions here. And so I put a little reminder here. Hopefully you copied this down in class, but if not, I'll go through it quickly. These next two, 19 and 20, are going to deal with horizontal and vertical lines. So that's what this Hooy-Vux thing is for, and we've talked about that in class. So, over with Hooy, we have horizontal. This zero, this O is really a 0, and it's the slope, a slope of 0. And how you would get that is if you had 0 on top of a number when you find the slope. And then the equation of the line is y equals a number. And so over here, we have vertical lines. The slope is undefined. So when you plug it into the slope formula, you get a number on top and 0 on the bottom. And the equation of this line is x equals a number. And so a horizontal line, remember, it looks like this. And a vertical line looks like this. So we want to keep these ideas in our mind as we answer these next two questions. So we're not going to have a lot of work to do. We just want to kind of think through. So this one says, write the equation of a vertical line that passes through the point -2, 6. And so a vertical line, I want to look over here. A vertical line has an undefined slope, and the equation of a vertical line is x equals a number. So if I'm writing the equation, I'm going to use x equals, well, what does x equal? I'm given a point. If this is x and this is y, x is -2. And the thing about a vertical line is that x always equals -2. It doesn't matter what y equals. So that is the equation of the line. That's all I have to do. So looking at the next one, we're writing the equation of a horizontal line that passes through the point 310. So it's the same kind of thing. A horizontal line over here. A horizontal line has a slope of 0. And the equation is y equals, so I look at my point to see what y equals 10. And for a horizontal line, y is always going to equal 10 no matter what x equals. So there you go. Those are pretty simple. You just have to think through them. So these are our last two problems. They are both word problems. So we did a few of these in class and for homework last night. So we're going to be trying to write the equation of a line given these situations. So, as always, I'm just going to read and try and figure out what's going on first before I dive into the math. So 21 says, for babysitting, Nicole charges a flat hourly fee of $10 plus $2 per child. Write an equation for the money M. She will make babysitting K kids, K is your variable, kids, for an hour. Okay, so Nicole is babysitting and is just talking about how much she charges per hour. And so it says she charges a flat hourly fee of $10. So a flat fee means it doesn't change. So every hour she's going to charge $10 no matter what. But then it says plus, which is important to know, think of these math words, this is plus $2 per child after that. So the rest of it is just defining our variables. So it's telling us money is going to be M, and K is going to represent the number of kids or children. And we're just finding her hourly rate. So because she increases her rate based on per child, it's going to increase at a constant rate, $2 per child. This is a linear situation. And so we're going to use the equation y equals mx plus b. However, when I'm working with word problems, I sometimes put these in the form y equals b plus or minus mx, and I'll show you that just with this situation. Either way is fine. If you want to put it straight into y equals mx plus b, that is totally fine. So where, and I kind of went over this in class today too, I kind of want to define these things. So I'm actually going to erase this one so I can explain my thinking here. So y is going to be, Y is going to be like a total value. And B is usually like a starting value or a constant value. And then our plus or minus, we have to decide it's going to be plus if we're increasing and minus if we're decreasing. And then this here, the mx kind of term, is going to be our changing value. So when we look at it in the context of this problem, our total value that we're solving for is the money that Nicole makes or charges when she's babysitting, this M value. So that's going to be our Y. M equals the total money she makes equals, well, her starting value or her constant value is $10. She's going to make $10 no matter what. She charges $10 an hour, but she also charges plus $2 per child. So that word per, remember, means that you're multiplying. So it's going to be $2 times however many children she has, and it tells us here that that's going to be K. So this equation represents how much money she's going to make each hour. So she's going to make $10 plus $2 per kid. So if she's only babysitting one kid, if we put in 1 for K, she's making 10 plus 2 times 1, which is 12. She's going to make $12 an hour. But if she's babysitting 5 kids, we would plug in 5 for K, so that's 10 plus 2 times 5. 2 times 5 is 10. 10 plus 10 is $20, so she's making $20 an hour. So I hope you can see how this equation is useful, and Nicole can figure out how much money she's going to make an hour, depending on the number of kids she's babysitting. So we're going to move on to this next one. It says, the current water level in a swimming pool is 6 feet. The water evaporates at the rate of 1/3 inch per day. A says write a linear equation to find the water level W after D days, and what is the water level after 1 week. So we kind of want to break this down and think about what's happening here. We've got water in a swimming pool, and the water is evaporating. So when water evaporates, I'll draw a little picture over here. The pool, I want that to be blue. The pool water, it's evaporating, which means it's going up into the air as the sun hits it. And so the water level will actually be decreasing as water evaporates. So that's an important thing to know, that evaporation is causing the water level to decrease, or we're going to be subtracting for this problem. So now I want to pay attention to my numbers and kind of plug in to my Y equals mx plus b, or y equals b plus or minus mx situation. So the current water level is 6 feet. That is like my starting value. The water evaporates, so it's decreasing at the rate of 1/3 inch per day. And so I'm writing a linear equation to find the water level W after D days. So my total value in this situation would be W, the water level. The water level is equal to my starting value, which is 6 feet. Then the water is going down, so I'm going to do 6 minus. Okay, we have an interesting situation here because this is feet, and I'm decreasing at 1/3 of an inch. So I actually want to be careful. My units need to match. So I have 6 feet, and I have 1/3 inch. So I'm actually going to convert this 6 feet into inches. So I'm going to go back here. I'm going to erase this. I'm going to do a quick conversion on the side. I will not ask you to do unit conversions on an assessment because that's not a standard we have really taught or worked with this year. So, but this is good practice. So to do a conversion, I have 6 feet, and I'm going to multiply that by 12 inches per foot. So these units of feet cancel, and then I'm left with 6 times 12, which is 72. So I have 72 inches. Is the same thing as 6 feet. So I'm going to use that number instead. So 72 minus, because the water's evaporating, now I can just plug in my changing value, which is this rate of 1/3 inch per day. So that's multiplying, it's going down 1/3 of an inch per day. Okay, so that is my equation. And then it says, what is the water level after 1 week? And so we've got to actually convert units again. This one, I know that there are 7 days in a week because this time piece here is days, not weeks. So that's why I had to switch that. So we can, if I want to figure out the water level after 1 week, I would just plug in 7 days for D because 1 week is 7 days. So to find the water level, I'm going to do 72 minus 1/3 times 7. And so when I simplify this, I get 72 minus 7 times 1 is 7 divided by 3. So 72 minus 7 over 3. I don't really have a calculator handy, so I'm going to have to do this in my head or the long way. So I'm going to do this off to the side. You can plug it in a calculator though. So I need to get a common denominator here. So I need to multiply top and bottom both by 3. Oops. So I get 72 times 3 is 216 over 3 minus 7 over 3. So I get 209 over 3 when I subtract this. So W equals 209 over 3, and that doesn't make a lot of sense in the context of this problem, so I'm going to go ahead and divide that out. 209 divided by 3 is approximately 69.67, and this is the water level, which is now in inches because I converted this. So the water level is 69.67 inches. So if you're interested in what that would be as feet, then you could divide it by 12 inches to get it in feet. Lots of unit conversion here going on. So I'm left with 5.8 feet. And so I want to check, it should be going down, and sure enough, that water level is going down from 6 to 5.8. Trying to think if that makes sense. 1/3, so it should go down, so 1/3 of an inch. 1/3 of an inch. Yeah, that does make sense, I think. So that is how much water, that is the water level after 1 week. So the main things here are knowing how to plug in. That is something you should know how to do for the quiz tomorrow. But this example was a lot tougher because we had to do some unit conversions. You will not have to do that tomorrow. So know how to use this idea over here to write a linear equation, and then you need to be able to know how to plug in values to solve for something in a linear equation. So go ahead and make sure you check over these, feel good about them. Come to class tomorrow with any final questions. Like, Mrs. Montgomery, I tried this problem, I checked my answers, I watched your video, and I'm still confused. Those kind of questions are acceptable tomorrow, and I can try and address that before we start our quiz. But I think that you guys can do a great job. Just follow these steps, do your practice, and I look forward to seeing you tomorrow. Best of luck.